Hey guys, welcome to my channel. I'm Coder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have an amazing problem that I'm very excited about. So this is a very good problem, man. I'm saying. So let's go ahead and read the problem statement. All right. So it says serialization is the process of converting a data or object right into a sequence of bits so that it can be stored in a file or memory buffer, right, or transmitted across a network connection linked to be constructed later in the same or another computer environment, right? Okay, so pretty much serialization, I'm saying it's a way for us to pretty much whatever data structure I convert data structure some kind of I'm saying it's a sequence of bits, right? So you can start a file. So I'm saying things some kind of string, right? I'm saying so sequence of bits, right? I'm saying or memory buffer or transmitted across a network, right? To be constructed later. So cool. So it says design an algorithm, right? I'm saying to serialize and deserialize a binary tree, right? There is no restriction how you serialize or deserialize algorithm might work, right? I'm saying you should ensure that a binary tree can be serialized to a string, right? And this string can be deserialized to the original tree structure, right? The input output format is the same as how LeetCode, you know what I'm saying? You do not necessarily need to follow this format. So please be creative and come up with different approaches yourself, right? We're saying LeetCode serialize and deserializes, kind of, I'm saying like that. I'm saying by using, I'm saying, but it's not important to understand this problem, right? So pretty much, there's two things, right? And I'm saying, they're saying that, so we need to serialize our data structure and our binary tree, right, into some kind of a string, right? And then deserialize it, right? And which is the process of converting it back to its original structure, right? I'm saying, so we need, that's kind of the ask that we need to do, guys, right? So we need to pretty much think of clever ways to pretty much serialize what I'm saying. So you're given the structure, right, convert into uh to a string, right? And then deserialize it again, right? You know what I'm saying? Because they might use it, you know what I'm saying, on a computer, and they might serialize the structure, right? And then in the other computer they want to deserialize it, right? You know what I'm saying? That might be, some kind of purpose that, you know what I'm saying, some use case for that, right? So pretty much you can kind of think of it as, we're given, we just got a brand new job, right? And we're given a simple task to pretty much get that done, right? So pretty much we're gonna impress them by doing, I'm saying, by solving this task in the most clever way possible, in ways that they couldn't even imagine, right? So we're gonna press down what we're gonna do good, guys. So how can we serialize the structure and deserialize it, guys? I'm saying what kind of thinking that are needed to solve it, guys. So because of that, what we're gonna do, guys, brainstorm. We're gonna go to our what's it called? Our whiteboard, right? You know what I'm saying? This is where we kind of brainstorm ideas, I'm saying, before we get into the code and the algorithm, right? So we're given this root, guys. I'm saying, how do we convert that to a string? At the same time, making it convenient, you know what I'm saying, making it easy enough, I'm saying convenient for us to, when we're doing the deserialization, right, which is the process of converting it back to the actual binary tree, right? We need to make sure that we don't, mess ourselves, right? So the serialization needs to be simple so that our deserialization, right, we can easily do it, right? You know what I'm saying? In a simple way as well, right? We don't want to shoot ourselves in the foot, right? So, what I'm thinking about what we can do, guys, I'm saying, I think we need to do some kind of traversal, right? So let's run through the different traversals, right? I'm saying, and see if something stick, right? So let's think about breadth of search, visit things level by level, right? How can we say like, so we put 1, 2, 3. Would that be easy for us when we do serialization? I don't know because we don't know how many children that two belongs. I mean, children two has, right? Would we also need to add the null values in there? How would that work? I forget. There's a way you could do preference search. I think that will work as well. Yeah, yeah. Do level by level, right? So we could, you know what I'm saying? And when we deserialize it, we do it the same way, right? So that yeah, just that could also work. Another way that I like that, the code is very simple for, right? Definitely the thinking pre-order traversal of the tree, right? For serialization, right? serialization, we could do one. All right, so pre-order traversal is the root, and then we visit our left and right side subtree, right? This is exactly what's going on here, guys. We can do, right? So we can pretty much, I'm saying, eh, pre-order. So we visit the root, then we visit our left side, right? So pretty much how we're gonna do it, guys, right? Pretty much we're going to have a delimiter, which is going to be the I'm saying comma, right? So we start with the root, right, which is one, and then we visit our left side, right? I'm saying, right? We visit one, we visit our left side, right? Which is what, two, guys, right? Two, and then we visit two. We also need to add the null values, right? So that we know that two has null nodes, right? I'm saying as there's no children, right? I'm saying so XX, right? Right. So they're pretty much those are nulls, right? I'm saying pointing to null values, right? XX, okay. All right, once we have that, guys, right, we visit our, so now there's nothing more to visit, right? I'm saying, so now we visit the right side of one, right? So now three is right there. And then three adds itself to the string, right? Because we're building the string, guys, in a pre-order fashion, right? A pre-order traversal, I'm saying. So it's root first. So I visit three, right? I'm saying, and then I visit four, right? I'm saying, right? I visit four, right? And four, it's gonna visit, you know what I'm saying? It's null children, you know what I'm saying? We're gonna account for as well. So we don't, so we when we do deserialization, we account for them, right? And we know those are null nodes. We know that four is not pointing to anything, right? I'm saying. So after we visit that, right, and now the only thing that's left is to visit five, right? I'm saying. And just like that, guys, we have our string, right? We have a string that we want, right? I'm saying. So now how do we deserialize it, right? I'm saying that's kind of the issue now, right? So okay, so how do we know do we use an index to know the nodes that we've processed before, right? Do we some kind of index, right? So how do we deserialize it? So okay, we visit one, I'm saying, and then I can index plus one, right? And I could be at this one, and then I visit two, and then I do XX. And then I do index plus one, need to maybe have an index as a global variable, maybe, so I can know which part I'm pointing at, so that um, I visit the nodes in the pre-order one that I want, right? I'm saying we can kind of think of complex ways, right? But an easy way, guys, that I know that we can solve this problem, right? Easy way is going to be to use a queue, guys. A queue make our lives a lot easier, guys. What I'm saying. Because the queue guys, I'm saying, we process the nodes, right? I'm saying, so pretty much we would uh, put all of the different elements that we have in the string, right? I'm saying, so the delimiter would be um, the comma, right? I'm saying we'll split it, right? Put in some kind of array. So now all the nodes, right? I'm saying will pretty much be some kind of I'm saying collection, right? I'm saying one, two. I'm saying pretty much we know what we have here, right? X, X, three, pretty much everything you have here, right, in the string, right? I'm saying X, X, and then five, right? Okay. So we have these right in there, right? So now what we do, we put all of those elements in a kind of queue, right? Queue, everything are processed in the way they are in, I'm saying the order that they are in right now. First in, or gonna be the first, I'm saying out, right? Which is what makes the queue effective, right? And then now we could pass the queue around and some kind of function that we have, right? I'm saying that every time we just get the thing at the front of the queue, right? We check if it's a null node, right? If it's a null node, we return null, right? If it's not a null node, right? I'm saying we pretty much so let's quickly do it, right? So yeah, so now we at one, right? So one, we create a node for one, right? Because a pre-order, right? I'm saying create a node for one, and then now we pass in, we go to, I'm saying, a left side. We see, no, the child's not null, right? So two, right? Two, so two, I'm saying, and two, right? And then now the next thing that it's gonna do, right? Two is gonna visit its children, right? So now they're both null, right? Because of what's in the string, right? I'm saying, because we're gonna do queue that poll, so those things are gonna be out of the queue, right? I'm saying as you go, right? So now at the front of the queue, we have a null, right? So there's nothing points null. I'm saying null. So that's what we have for 2, right? So now those have been processed, right? So now 3 is at the front of the queue, right? What I'm saying? So now we be done, right? So now we go to the right side, guys. What I'm saying, because 3 will be at the front, right? What I'm saying, and then now we're gonna pretty much you see it in the code. It will make a lot more sense once you see it, right? So now we do 3, right? We do 3 first. I'm saying because of the pre-order that we're doing, right? I'm saying, we've processed the root, the left side, and then now the right side. What's the left, right? So we'll do the same thing, right? So now for 3, right, we're gonna go to the thing, right? And we see that 4 is the node that's next. What I'm saying so 4, right? And then 4, right, is gonna pretty much we know the left side of 4 is null because of the X, right? I'm saying, see what we're getting there. And then we see that the right side of 4 is null as well, right? Because of the X, right? I'm saying. And then we see that the 5, no, so now we're done, right? I'm saying there are no more nodes, right? To go and check, right? So now automatically we just go to the I'm saying to 5 now, right? Which is 5 resides on the right side of 3 because I'm saying the children of um 4, they're null, right? So they can't belong, 5 can't belong to any of them because they're null, guys. This is why how we're doing this, right? This is how the recursive thing's gonna work, right? There's nothing to process, so it goes back up and it goes to the right side, right? I'm saying we know how to do recursive functions here, right? And then now, just like that, guys, we're done. And obviously those are null, right? I'm saying those are null, right? I'm saying null, right? And just like that, guys, we look like we have the exact tree data on that's pretty much right there, guys, right? I'm saying. So now that we get the logic down pat, right, we know how to serialize it, right? We do a pre-order traversal, right, to serialize it, right? And we use a delimiter, which is going to be the comma, right? I'm saying, and once we encounter a null node, we put an X to signify that that node is null. I'm saying this is why. So the two things that the couple of things that you need to take into account, right? When you solve this problem, guys, the delimiter, right, to separate the different nodes, right, values, and also the X to signify the null node, right? And then we use for visualization, right, we use a queue, right, to put all the different elements right into a queue so that we can easily do the traversal. I'm saying the pre-order traversal, and we visualize it in a pre-order fashion, right? And by going to pre-order, I'm saying. And yeah, so I think we got the logic down pack, right? So the queue is gonna be passed by reference, right? So we just pass in the queue. That's all we need to worry about, right? And all the time as we visit the nodes, right, we obtain what's at the front of the queue, guys, which is an important aspect, right? Whatever's at the front of the queue is what's gonna be at that node, at that particular node, right? I'm saying. So let's quickly go ahead with implementation, guys. So what we're gonna do, guys, we're gonna be using a helper function, right? Let's call this serialize. I'm saying helper. I'm saying let's call it helper, guys, right? And then we're gonna pass in the root, right? I'm saying. So public, right? Um, okay, we're almost there. Public string. We're gonna call that serialize helper, right? We're gonna pass in the tree node. Okay, so if that node, guys, right, equals to null, right? We said that the convention that we're gonna use, right? We're gonna be using that X, right, to signify this is like a null node, right? And after we do that, let's get our string builder ready, guys, right? Right. Yeah, so after we do that, what's gonna be next, right? So now I told you guys it's a pre-order, right? You're gonna do it serialize in a pre-order fashion. So now we do root that val right at the root first, right? And then what we're gonna do, um, and then we're also gonna do that append, right? We're gonna add a comma, right? That's the delimiter, right? Okay, so now we also need to visit our left side, right? I'm saying. So we use serialize helper, right? Pass in our left side, guys, which is important, right? And then we also make sure that we add our comma, right? And then we also need to visit our right side, which is equally as important, right? 'Cause we want to serialize. We don't want half data, right? We want everything as it was when we deserialize it, right? I'm saying. So that's what we do in this, guys, right? So after we serialize, our value on the left side and our right side, what's next for us to do is to return that to our parent, right? So that they can get our answer, right? So every node is pretty much they're gonna serialize themselves and their subtrees, right? And then return to a parent, right? And then the parent's gonna add them to the result, right? So now we've gotten the thing that we want, right? So everything's serialized. So now we're gonna do um a serialized function. That's when the fun begins, right? So what we're gonna do, guys, we're gonna do string. We might just call it datas, right? And we're gonna pretty much, like I said, we have a delimiter, right? So we want to convert everything into some kind of array, right? I'm saying so that we can address every element independently, right? So what we have here, guys, right? So the data that split, right, splits everything on the comma, right? So um I'm saying so the I told you guys how the thing looked, right? Saying so things don't look like that, right? I'm saying um because 5xx, right? Yeah, so they look like that, right? So we need to pretty much put everything in some kind of, so the delimiter is a comma, right? So that's what I'm doing here, guys, right? For you guys are following. So what's next, guys? Right, the next thing for us to do is pretty much, so now we have all of the, so we have 1, 2, x, x, 3, 4, I'm saying. So we got the array of those elements, right? What we're gonna do, I told you guys we're gonna be using a queue, guys, because the queue is very, makes it very convenient for us when we're doing the traversal, right? I'm saying. So it's gonna be a queue of strings that is gonna hold pretty much, guys, right? All of the at all, right? So the queue is pretty much gonna hold everything, all the data I'm saying that we have, right? So we do datas, so we do arrays, right, as list. Okay, so we pass in the datas, right? So the array, right? I'm saying we're gonna add all the elements into a queue, guys, right? So that I told you guys, we always gonna as we traverse, right? We're going to pretty much um pass in the queue, right? Easy, right? Yeah, public tree node, right? Because that's what we want, right? We want the original structure, right? This is where the return type is of tree node, right? You guys are following, right? Serialize helper, and the input is going to be the queue, right? That we said, queue of strings, right? Okay. So now, yeah, this is where the fun begins, guys. So what we do, right? We take the stuff out of the queue, right? I'm saying, so val, right? So we do queue that pull, right? So we know how to get stuff out of the queue, right? I'm saying, so after we do that, we're gonna do a check, guys, right? Is that a null node, right? If we was the val, guys, equals to a null node, right? If that's the case, what we do is return null, right? Because that's a null node, right? Because that's the convention that we agreed with, that when we put an X, those are going to be nulls, right? You could put whatever logic you want, right? But this is what we agreed upon first time, right? So we're going to keep it like that, right? Um, so if it goes to X, we said it's going to be a null, right? And if it's not that, right, it must be a value. So let's create a node, right? You know what I'm saying? Root, let's go to new tree node, right? And then val, right? I'm saying no, it's not only val. We need to turn that into because it's a string right now, right? Because we have a queue of strings, and we taking strings out of the queue, right? So we do integer that value of, right? I'm saying of the val, right? So that's gonna give us the integer that we want, right? So after we do that, right, we do root. And now we need to populate our left side, right? Because every node is gonna populate their uh gonna populate everything, right? I'm saying it can populate their left and right side because we serialize everything, guys, right? I know in the walkthrough, I forgot to serialize the last for 5, right? But we do that as well, right? I'm saying every children gets serialized, right? So we go to with that left, and then we do the same thing for the right side, guys, right? right? So root that right. Okay, and then after we do that, man, we return the root, right? And just like that, guys, I'm saying, because we're past, what am I doing? I'm tripping. I meant to put Q, right? We'll need to, yeah. So we just pass in the Q, guys, right? We pass in the Q for the left side, or it pretty much, takes care of the left subtree, right? I'm saying, because we serialized for the left subtree when we did it, right? And after it's done doing everything on the left side, right, it's satisfied, we go on the right side and we pass in the Q as well, right? I'm saying pretty much no real logic needed, guys, right? No real thinking, brain processing needed. You don't need to know which index, know how to know which one, how many nodes we're processing on the left side. We don't need to take care of any of that, right? The Q is gonna pretty much help us and pretty much pass it around because it's being passed by a reference, guys, right? Could easily apply that logic, right? I'm saying. Yeah, press run code, man, and see all the talk that I was doing. Let's legit, right? Okay, looks good so far. Let's press submit. See if we pass all the test cases, guys. Awesome, guys. We're able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch this video, guys. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.